Thank you. All right, good afternoon. This is probably your last session at TC about your probably favorite feature in Tableau, sets. So thank you for coming. I hope this is a great way to close the conference. My name is Filipos. I'm a product manager at the development team here at Tableau. This is a picture of my sister, Vanessa, and I. The reason I put this picture up here is because I think these two facial expressions perfectly describe my first reaction to Tableau when I first opened the product. This is the awestruck look in Vanessa's face. And my look right there is actually the exact expression I made when I first defined and used my first set in Tableau. True story. Moving to the present, I graduated from college last year from a tiny engineering school in Boston called Owen. And after a series of amazing hikes in the country, I moved to Tableau as a full-time product manager last fall. And Seattle pretty much looks like this. That's where we're based throughout the year. If you haven't been to Seattle or if you've heard rumors, don't believe them. This is the exact same picture taken on December, January, and July. So when I do not enjoy my time, with the sun in Seattle or playing with Tableau, I travel across the country. I've done some pretty nice hiking. This is a picture from Glacier, a phenomenal lake called St. Mary Lake. And this is a picture from Zion National Park in Utah, Angel's Landing, a phenomenal hike. I really recommend you check it out. So if you don't have any questions about sets, definitely about hiking, we can talk about this after the session. But enough about me. Today is all about sets. I think it's an exciting week for data, but an amazing week for sets. We just saw one of the most awesome features demoed at Devs on Stage yesterday called Set Actions, a way to visually select values and pass them to a set definition. And this new feature coming in 18.3 is going to make all of the applications I'm going to show you today instantly interactive for all your consumers. So it's going to be a game changer, and hopefully all the things we look at today will be even better for your future visits. So my goal is to really walk through a bunch of examples today and show you how you can use sets to answer common business analytic questions. We're going to walk through many of them. We're going to move fast. My intent is to show you as much as I can. This session will be recorded, so don't feel the need to keep notes or take pictures. If you ever want to review that content again, we'll have in the portal posted the workbook that I'll show you today and this recording. So what are we going to talk about? We're going to first look at customer segmentation, so ways of using sets to identify customers that haven't bought a certain product and use combined sets to get further answers to questions that may come up after this. We're going to look at dynamic grouping, ways in which we can use sets and calculations to create cohorts in our data and have those change as customers interact with parameters in our view. We're going to look at benchmarking, one of my favorites. Very common for scenarios where we have a portfolio of customers and you want to see how that portfolio of customers is doing compared to the average expenditure at a certain level of detail. We'll use sets to get this answer super easily and super fast. We're going to look at measure comparison, a way to perform part-to-part comparison, and look at how we can use sets to filter specific axes in our visualizations, and really decide what level we want to filter at any given viz using sets. We're going to look at market basket analysis, very common application in different industries. Cohort analysis, especially powerful in marketing scenarios, looking how we can segment our customers into cohorts and see how maybe they're doing since the first time they bought something for our company. We're going to look at conditional suppression, very important for HR, applications, and data security, and use sets to conditionally unveil information in our view. Comparative ranking, a super awesome way to apply table calculations with sets and see how we can look at different rankings of certain products, categories at different scopes in a single visualization. And finally, we're going to look at asymmetric drill down, which is a way to specify which path you want to go down a certain hierarchy and compare values across different levels of that hierarchy in the same view. Danny at Devs on Stage showed this tree map of countries and sports and athletes, right? And he drilled down to a single element in that tree. This is going to be a sneak peek of how this works behind the scenes, and we're going to also use set actions to wrap the session off. So hopefully it's going to be a cool indicator of how you can use this new feature going forward. So a pretty packed agenda, so let's get started. I'm going to go over to Tableau. And I'm going to be going under here to switch the screens. I'm not having any flasks or any other drinks. under here. All right, there we go. Perfect. All right, first example, customer segmentation. So let's say we're a wealth management firm, and we're looking at figuring out which high net wealth customers haven't bought a certain stock, okay? And by the way, I'll be looking at these examples using Superstore, so you can all relate to something you've seen. But imagine this maps to any given data set or industry you may use Tableau in. So in this case, I'm using subcategory in Superstore nomenclature to specify my stock ticker. In this case, shares is representing the best stock in the New York Stock Exchange market data. If I change shares to envelopes, we notice the viz updates. This shows us that these high net wealth customers have not bought this particular subcategory, or in this wealth management scenario, this particular stock. So how is this viz built? Well, fundamentally, I'm going to start from scratch, and I'm going to look at customers, sales they've generated, and each customer is broken down by the subcategory they've bought something with our company. The first step is to define a set at the customer level that finds all customers that are considered high net wealth, all right? And to do that, I'm going to go over to my schema over here, pick customer name, and create a set. And this is going to be my customers, or my high net wealth customers. Now I'm going to use all values in my field, but condition that set with a formula. And this formula is going to look at the aggregated sum of sales at the customer level of detail and compare that sum of sales to a threshold that I define as these are my high net wealth customers. So I'm going to look at the sum of sales, and I'm going to look if that value is greater than this parameter right here, my high sales threshold parameter, which is in this case $8,000. So I'm going to simply reference that parameter in here, and I can save that set of customers, and this set will get added to my data model. So it's stored right here in my data model for later use in any way I may want to do that. So we've answered the first question, which are the high net wealth customers, but we still haven't found the customers that have not bought a certain subcategory, a certain stock, whatever the case may be. Now this is another customer set, but this customer set will be conditioned at a different level, based on a different condition. So I'm going to go over to my customer name field and define a new set. And in this case, these are going to be my customers that have not bought X. All right? I'm going to use all values once again, but I'm going to apply a condition to that domain. And that condition is going to be the following. I'm going to try to find each row in my table that has a subcategory value equal to my parameters subcategory value, which I'm using in this dropdown. So I'm going to maybe type in, okay, for any case that my subcategory parameter equals my subcategory, give me 1, else give me a 0. But Tableau gives me an error here. And the error is that the formula must be an aggregate calculation. That is because any calculation we write in the sets dialog is trying to find information at the level of the field that my set is defined from. So what I need to do here is I want to find the max of all those results at the row level and fix them at the customer name. So all I'm going to do is I'm going to say, okay, get the max of this. And when that equals 0, so whenever I don't have a row in which a customer has bought that thing, add that customer to my set. And I'll save the set, and I'll move to Excel to show you this in a more tabular form to conceptualize how the max function actually works. So I'm going to pull up Excel, and I have a very simple table here. I have customer. I have 3 rows for Bob and 2 rows for Ann. I have products each of them has bought, and the sales value for those products. So in the set dialog, we wrote this first calc checking if product equals X. And this returned at the row level 1 for this row and 0 for all the other rows, right? It checked this value and got 1 or 0. But our question is at the customer level. And Tableau can use that calc defined at the row level to find information at this column's level of detail. So now what I really want is I want to do a per customer calculation and get the max number for each of the rows that equals Bob and each of the rows that equals Ann. So if I simply do the max of product X, this is going to give me at the customer level, the max of 1, 0, or 0 is 1 for all these rows. But the max for 0 and 0 is 0. So in this table, it seems like Bob has bought X. And that information is translated at the row level, but also fixed at my customers. So this is exactly what happened in my set dialog, right? So now I have these two sets, these two customer sets. One for high net wealth, one for customers that have not bought the specified subcategory. I can simply combine those two sets. And the intersection of those two are high net wealth customers that have not bought X. So I'm going to type this. And by the way, I'll be typing and making mistakes, so please forgive me. High net wealth customers that have not bought X. And this is just the intersection, the shared members of those two sets. I can use the combined sets feature because those two sets are based on the same dimension, customer. I'm going to zoom out, save this set, and bring it right into my view. This is going to filter down my viz to customers that match those conditions. I can come over here, change the input parameter, and my viz updates to reflect which high net wealth customers haven't bought that product. Pretty cool, right? All right, ready for the next one? It gets better, trust me. All right, so next one is about dynamic grouping. So a super cool thing that we can use sets for is to define those superlative conditions. I want to find out my top 3, top N performers, states, and see how those top N performers compare to other data in my view or in my data set in general. In this case, I've defined a set at the state level, and I'm looking at how do each of my top 3 states by sales compare to the overall sales produced by all other states in my table. I can change this parameter on the right side of my viz, and you can see that Tableau adds new lines. Each line is a new set member, but it also updates this other calculation to include all other states that are not in my set. So how does this work? Let's build this from scratch so we see exactly how we can make this happen in Tableau. I have this viz that shows all of my states running sum over time. All right, and I have this parameter which if I change, nothing happens because I'm not consuming it anywhere. I haven't defined a set yet to consume that parameter. So I'm going to get it back to 4 and go over here and define a set for my state field. Now this is going to be my top N states. I'm going to use all values, all states in my fields domain, and pick from the top tab a condition that basically tells Tableau, hey, pick up all these states that meet that superlative, that rank condition. Give me all of my top N states by sum of sales. I'm going to zoom out, save this set, and use this set in my view as a color indicator. So we're starting to get there. So we're seeing the blue lines now and a bunch of gray lines. I can change this parameter value from 4 to 3 to 2, and I see Tableau reflect that encoding in my viz. However, my question was, I want these all to be into one line. So how do I get that? Well, the power of sets that we can use sets in calculations and use them in calculations to derive conditional information based on their members. So let's write a calc that tells Tableau, I'm going to call this top N or others, that tells Tableau to look at the row level of my table. And for each row that have a state value that is in my set, I want Tableau to give me back that state's value. Else, I want to give an alias to all other rows that I'm going to call other. I'm going to end that conditional. So simple calc, right, that checks if a state is in my set. By the way, this syntax is completely confusing. When I first saw set syntax and calc, I was like, how is this working like this? But basically, all this is doing is it's checking if this equals true, right? For any given thing that is in my set, give me something else, do something else. So I'm going to save that calculation. And now the power of this calc is that I can substitute my LOD. I can bring this calc and substitute my state pill in the marks card. And notice what happens when I drop this on the marks card. Now Tableau picks up all the gray lines, gives them this other value, right? Bins them into one entity and displays that in the view. I can use that calculation as a label, and boom, right? I see now members in my set, out of my set as I'm changing my parameter, my set updates, my calc updates, my LOD updates. Pretty powerful stuff. Now the next thing, I have a challenge exercise in the dynamic grouping examples. I think it's interesting to think about ways you want to count members in your set when you want to conditionally bin those elements in your set. So let me explain what I mean by that. So imagine this viz, right? As I keep adding members in my set, lines get cluttered. And I maybe want to see the holistic contribution of all my set members as one line. So how do I group the blue lines now into one line? It's a bit more complicated, so let's see what happens. So I've defined here a threshold. I've called it member count threshold. That is equal to 5. And I currently have 3 members in my set: California, Texas, and Washington. I've defined that set, so I'm going to go over here and show it. And what I'll do is I will add some members to my set. Now I've told Tableau, hey Tableau, if you see more than 5 things in my set, give me one line for them. Don't show them individually. So I'm going to go over here, add a couple of states, or more than that, in this case 5 states. And notice what happens when I click apply. I'll click apply, and all my blue lines now get into one line. It's more important for me to see the aggregated sum of those results instead of cluttered lines for which I cannot really decipher which state is which. Now, how does that work? So for this to happen, we need to leverage level of detail calculations and sets. So again, starting from scratch, we see all state running sum over time. I have a parameter, I change it, nothing happens, I'm not consuming it anywhere. Now I've defined a set for us, or I will define one for us rather. From the state field, it's going to be an arbitrary number of states. Let's say these are the states with X members, and I pick California, Colorado, and Delaware. I'm going to save that set. Once again, it gets stored in my data model. And now I want to use that set in a calc to understand how many members are in it and compare that count to my parameter threshold. So I'm going to go and create a calc field, and once again, I'm going fast. You'll be able to press pause when you want to review those in step by step, but I'm just trying to give you as much awesome stuff you can do with sets as possible. So what are we going to do here? So here we're going to write a calc that checks the count of our set members. Okay, and this is going to go and do the following: members. This is going to go and say, okay, let's first look at our set. And for all rows that are in my set, I want to write a conditional, a nested conditional, that checks if my count of all the unique states returned in my set. So I'm going to do this calculation here that returns states. So this gives me the unique count of states in my set. All right? And I'm going to check, okay, well, if that count is less than the threshold that I have defined in my view, what do I call this? This is a classic Filippo's error, not remembering how to name things. There we go. If it's less than the threshold that I defined as my count, then I want Tableau to give me the states. Else, I want Tableau to bin those states into this in alias. I'm going to close that nested conditional, and then outside of that, also I want to see all things out of my set as one line, so I'm just going to say else out. Right? So that's it. So now I've told Tableau to look at the set level, make a decision based on the member count, move out, and then bring all other members out of my set into one line. So I'm going to save that calculation, that very verbose calculation, and I'm going to first bring into my view my set. So we see, again, in this case, 3 colored blue lines and a bunch of gray lines. And I'm going to bring the calc we just wrote as an LOD pill. I'm going to drop it here, and Tableau now has 1 line for out and a couple of lines for all my states in. That's because my threshold count is 6 and my members are 3. I can bring this down to 2, and Tableau gives me 1 line back. Right? And you can play with the counts here. And this becomes especially powerful with set actions. I'm going to show you that later on, where you can use your selection to drive that calculation itself. All right, next one of my favorites, benchmarking. So very common application is for you to have a portfolio of customers, right? And you want to find out their average expenditure per product, per subcategory, per something, right? And you want to compare that. You want to make an actionable comparison to the overall average of your table. So in this case, in my left pane, I have a bar indicating the portfolio sales per subcategory. I have 2 customers in my portfolio, Amy and Alan. And as a reference line per cell, I have defined the average expenditure for all of my customers in my table. So it looks like my portfolio is doing pretty good in storage, but unfortunately, we're selling shares at a very low level compared to the average expenditure of sales throughout the entire table. Now, on the right-hand side of the viz, in the right pane, I'm showing the difference between these 2 values, so you can compare and see, huge deficits here, for instance, for the phone category. So how does this work? So maybe the first instinct here is to use a filter. Maybe you're thinking, okay, let's drop my customer name on the filter shelf, pick up Amy and Alan, save that filter, and we now see how much the average sales for those 2 customers is. Now this works, but unfortunately you cannot see what subcategories these customers haven't bought. And as a result, you cannot find those deficits we previously showed here for the phones, machines, and other scenarios, right? So you want to have context of what are the things we're offering and where's my portfolio actually contributing value. So to do this, right, sets are just the right trick, because sets let us filter. I'm going to remove this filter. Sets let us filter at the pill level, right? Filters filter at the sheet level. But if I use a set in a calc, I'm only filtering one column. So let's see how this works. I've created here a set, our customer portfolio. It has the exact same folks that I included in our filter, Amy and Alan. I'm going to save this set. And I'm going to use that set in a calculation. And all I will tell Tableau to do is give me the sales for my portfolio. And these are the sales values at the row level for which we have customers in our set. What did I call this? Portfolio. So this is going to give us the sales for all rows that we have a customer in our set for. So notice what happens when I save this calc and use this calc in the view instead of the average sales pill. I'm going to sort this view. Now we see the sales we've made at that portfolio, but we also see these null entries, which will help us derive the difference between the total average and the portfolio average. So next step is to find the overall average, right? We have now the average in our portfolio. How do we get the overall average? I built this calc for us to save some time. All this is it's saying, let's pick up the total sum of sales and divide that by the distinct count of customers in our table. This is the average sales per customer, and when used in the viz, it will aggregate at the level of subcategory. So I'm going to zoom out, bring this calculation on detail, and add a reference line that brings that calculation in the view. Per cell, pick up average sales per customer, remove the labels, maybe make the lines a bit bigger, add some color to them. And now we can see quickly, right, portfolio, average sales, and overall average sales per subcategory. So final step is to get the difference between these two. Sets let us easily compute calculations within those derived fields. So all I'm going to do is I'm going to make a new calc that I'm going to call difference. And what this is going to do is going to pick up the average sales from my portfolio and subtract from that the average sales per customer. Now we had some null values returned for this measure in this viz. All I'm going to do is I'm going to tell Tableau to make those null values zeros with this function we have called zn. So I'm going to zoom out, save this calc, bring it over as my right pane, and now we see information we were seeing previously, right, coming into form. Let's add some color to it, right, because we love color. I love color. So I'm going to bring over difference over here, and we're getting the results we wanted. We can maybe add this on label and get further insights on our data. So super fast using sets to filter at the level you care about and derive information without necessarily slicing data out of your view with filters. Pretty cool, right? Yes, awesome. All right, next one. This is a super cool example derived and inspired from Bethany Lyons, one of our sales consultants. This is using sets to perform part-to-part comparison. What I've done here is I have two sets of manufacturers, because I know that each of those two sets of manufacturers belong in a certain parent company group. And what I want to see is I want to see how do these set of manufacturers compete with one another at the state level. So for example, in New York, we look at group A sales versus group B sales, and they're close to this 45-degree angle. They're doing pretty good in that state. But for example, in Kentucky, right, group A set of manufacturers has to do a better job at catching up with group B. Now this is a funky viz because I'm effectively using the same measure, sales, in both axes. Before I use Tableau, I would see scatter plots with profit and sales or something else, right? I never actually saw a scatter plot that has the same measure in both axes. But the power of sets is that it let us filter at that context, right? And perform meaningful comparisons at any LOD we care about. Instead of state here, I can bring something else in, and this would just be working the right way. So how does this work? So we start off with a very simple viz, state level and sum of sales per state. I've created these two sets for us here, manufacturer set 1 and manufacturer set 2. Again, the first instinct may be to filter this viz. So what happens if I filter this viz by manufacturer set 1? I'll get stuff back, I'll get meaningful values back, but this will only be the values for my one set of manufacturers. So I won't be able to actually see the sales values for manufacturers in the other set. So instead of filtering the sales pill at the sheet level, I want to filter it at the pill level. So I'm going to use that set in a calc to derive the sales value. We've done this before. By the way, this will be the entire presentation. A very simple use of a setting calculation to do all these different examples, right? So here, I'm going to say sales for manufacturer set 1 is simply the sales returned for all rows in which manufacturers belong in that set, else 0 sales for those others. I'm going to zoom out, save that calculation, and duplicate it, and create the exact same one for my manufacturer sales set number 2. That's all I have to do. So now with those two calculations, I'm done, right? I'm ready to go and use them in my viz. I'm going to zoom out, clear this sheet because I don't need that anymore, and bring those two measures as my axes. Those two sales measures as my axes. And if I drop state in the viz, I instantly see how each of those states, I can make this maybe a circle, make them bigger, there we go. So I can see how each of those states now works as a market for each of those sets. Now, they were colored in the previous viz. What I did is I simply created a calculation to get the sum difference of those two values, right? So the sum of sales for MS1 minus the sum of sales for MS2 gives us a difference that I'm going to encode my viz with. And we're getting an error. What is the error? Oh, yes, difference already exists between sets. There we go. And using the set calculation in the view as a color indicator, we now see the encodings we previously saw in the original viz. Now, you notice this line here that I had as a 45-degree angle. This is a nice trick that I found about yesterday, so I included it in this presentation. I want to show you how it's done. So all you have to do, right, so here we're comparing information. That's the fundamental idea of this view. So if I used a trend line in this view, it wouldn't make sense because we're looking for a comparison metric, not a correlation metric, right? So instead of using this trend line that computes itself using data in my view, I want to instead have a simple 45-degree angle. So all I will do is duplicate this pill. Oops, sorry, there we go. On this other pane. So I get this now straight line of values because this is the same thing, sales for MS2, sales for MS2, right? And now I'm going to use a reference line on that viz So I get the straight line at 45 degrees because there's perfect correlation between myself and myself. And I will make those borders none, right? I will make the opacity go to 0. And I'm now starting to get what I want, right? So now I can just dual axis those two charts, synchronize, hide this header, and boom, right? We got the 45-degree angle with a very hacky way, but I think very useful way, right, when you want to compare information at that level. Awesome. Do we like that? Awesome. Perfect. All right, next example, market basket. Very common scenario when you want to see what portion of orders for each of your subcategories also contained orders for a thing you care about. In this case, all orders for paper contain paper, but I noticed that all binder orders, I have 275 binder orders that also contain paper. So I can derive information about how different people order multiple things in my table. I can change this input to be art, and I noticed that, again, binders is pretty much up there. I don't know why they're so obsessed with binders in Superstore. I can change to storage maybe. Still, Jesus. Tables. All right, maybe. I can't figure this out, sorry. So how does this work? This is using a parameter input in a set to create sets at the order ID level. This viz is showing me distinct count of orders, right? So I want to find out how many orders included the specified parameter input. So starting from scratch, I have a viz of my subcategories and my distinct count of orders. Here, changing this does nothing. I'm not consuming it anywhere. What I'll do is I'll create a set of the order ID field, which is here. And this set is going to be, I'm going to name this to be descriptive, it's going to be all the orders that contain category or subcategory X. I'm going to use all values. And in the condition, we will use the exact same logic we leveraged in the first example for customer segmentation. All we have to do is tell Tableau, okay, look at the parameter input. I believe I called this subcategory parameter. No, subcategory X. I told you, pretty bad with naming. Equals subcategory. And we need to max that, so we need to bring that result at the level of detail of our set. So when that returns true, this means that a row in our table contains that subcategory, therefore that row contained the thing we cared about. So I'm going to zoom out, click OK, and now just bringing this set right in the view lets me see, and I can rearrange those sets, by the way, to make the in the leftmost side. So now I just see the number of orders, I can change my parameter, and boom, the viz updates, and I can quickly see the proportion contribution of a certain input to my other set of values. Now, this can extend, right? We can add multiple inputs. So what if I want to see what portion of orders for each subcategory included papers or art? I have two parameters here, and all I have done, I'm not going to rebuild this, all I've done here is I've created a set that is called orders that purchased X or Y, and all this does is simply add an OR, logic statement in my max, which checks if at least one of those two inputs exists in my row, then give it back into my set. Now, this is pretty inefficient if I have more than 2 or more than 3 or more than 4 inputs, right? So what would we use to make that more extensible? You may be wondering, yes, sets. So what I'm going to do is I'm going to create a set of subcategories that I care about, all right? And I may have created this already. Yes, I have. So subcategories I care about is containing bookcases and chairs. I can add one more. Envelopes, doesn't matter. I can add as many as I want. And this will just work. It's magic. So I'm going to save this set, and I'm going to create a set at the order ID level like we did before. Oops, order ID. And this set of orders now has to be conditioned based on the members of the set of subcategories I care about. So I'm going to call this orders that include subcategories in my set. And in the condition tab, all I have to do is simply tell Tableau to look at the max results of the categories I care about. There we go. To look at the subcategories I care about, right? This is a set the set has 1 and 0 values. It's a Boolean entity. I'm looking at the max of that entity at the level of the order ID. So now, fingers crossed, this should work. So here we're looking at a viz. I'm going to rearrange these pills. That shows us the orders per subcategory that included at least chairs or bookcases or envelopes or fasteners. So a neat way to extend your market basket analysis with sets by consuming one set within another set. You will leave the session thinking the word set all the time. That's my intent. All right, number 6. We're getting close. Oh, this is my favorite. I lied. It's not benchmarking. It's cohort analysis. So this is super powerful for marketing scenarios. A common question is, okay, how can I compare the sales that I've derived from customer groups based on the first year they became a customer for our company? So here I'm looking at people that joined the Superstore market, that bought the first Superstore product in 2015. How have their sales been changing over time? Okay, what about folks that started buying stuff in 2016, 2017, and so on? I can even look at maybe the first 700 days of those customers and look at, for example, that folks that started buying stuff in 2017 are plateauing their contribution to our sales. But on the other hand, folks that have been a long-time customer are exponentially helping us, run our sales. So how does this work? This will be super fast and super easy. We need to start, first of all, by looking at the first time somebody bought something from our company, right? And I have here a crosstab that shows per customer their first purchase order and their last purchase order. And all these results are two simple LOD calculations that are looking at the customer level and picking up the min order date. This is the first time they bought something. Or, I'm going to show the other one, the max order date for the last time they bought something. So I have those two endpoints now that I can leverage to define the difference between them. Now this difference, we want to find out at the day level. We can do the month level, but let's do the day level for now. All this is a calculation, a date diff calculation, date diff, or I'm going to call this days since first purchase, that does a date diff at the day level between the first order and the last order. So this will give us back a number that we can use now as our x-axis in our viz. So we're very close. We're super close to get our results. I'm going to clear this sheet. And by the way, I can use this as a label, and we notice that the results make sense. Somebody that started buying our stuff on February of 2015 and had their last purchase all the way at the end of 2017 is about 3 years worth of days, right? So now I can clear this sheet and bring this calculation here as, oops, where'd it go? There we go. Bring this calculation in here as a dimension. And I can bring sales in my view. This looks pretty ugly. I can look at this as a running sum. So we're getting close, right? We're getting to this initial view of our cohorts in a single view. Now, the first reaction may be, okay, let's use a filter to look at 2017 or 2016. But I want to see all of those cohorts in context in the same view. So what I need to do is I need to find those customers now that are binned in each of those cohorts. The first step is to look at 2015. So let's create a set at the customer name that's going to be all of our customers that first bought something in 2015. I'm going to use all values, and I have to condition that set now. Now again, sets are always computed at the level of detail of the field that the set is based on. Imagine a set as a fixed LOD, right, but returns 1 or 0, true or false. So in this case, all I have to do is look at the date part per customer at the year level, look at their min order date, so the min year for that customer, and see if that equals 2015. These are all the customers that had their first order that year. All right? And I'm going to save this set. I have to create 3 more of these. Thank God I have them here. We shouldn't do it together. So I'm going to drag that on this folder, and now we see we have 4 sets, right, each for 1 year. This is simply the same calc, just equated to 2016. All right. So again, we're very close. Now the one thing we have to do is consume those sets in calculation and give aliases to each of the rows that will be displayed in the viz to be encoded correctly. We need to find those cohorts and give them a value. So this customer cohorts calculation here simply checks, again, at the row level, I'm going to uncomment these calcs for us. And of course, I typed this with the wrong name. Okay, which one are you? Nope. This, there we go. So this is a row level calc, right, that looks at every customer in our table. If they're in any of these sets, we want to give that row a new value of the year they first became a customer. So now that I have those aliases, I simply need to use this calculation in my viz to encode those aliases. So I'm going to save OK, drop that over here, and we have our cohorts. Right? A very simple way to filter at many different values, a single field, and see all that information in the same view. And of course, we can bring in the days since first purchase as a filter, look at all the values, maybe look at the first 2 years, so the first 700 days-ish of purchase, and play with this to understand how our customer cohorts have been performing over time. And as we extend this date range, we look at our initial customers of 2015, 2016, completely overpassing our recently acquired customers. Pretty cool stuff. Again, sets. All right, we have 3 more and plenty of time. I love it. So conditional suppression. I brought this up in the beginning as a common HR scenario. So you want to have this view that shows conditional information for some members in the viz, some that meet some condition. So in the Superstore language, I'm looking at here sales or distinct count of orders per subcategory. And I want to see the total number of orders for each subcategory. But I want to see the contribution, the number of orders per manufacturer for a certain subcategory, if that subcategory has less than N manufacturers. So if labels in my company is made by less than 9 people, show me how each of those companies contribute. And as I change this parameter, we notice that Tableau updates, suppresses that information, right, to show me conditionally either the total suppressed or the unsuppressed per manufacturer contribution in order count. So how does this work? This is a very simple set, once again, at the subcategory level, because we first want to check which subcategories are manufactured by certain manufacturers. So again, simple viz, distinct count of order ID, broken down by subcategory. What we need to do is we need to define a set at the subcategory field that checks the distinct count of manufacturers per subcategory. So this is going to be subcategories made by less than X manufacturers. And this can be, again, can be vacation hours in a department of a company, right? You can imagine those fields being translated to any data set you may be using Tableau for. So I'm going to use all values, and the condition here, right, again, leverages the fact that sets are fundamentally, again, a fixed LOD that gives me 1 or 0. So per subcategory, what is the distinct count of manufacturers? If that is less than my threshold, less than my number of manufacturers, then I want to see those subcategories unsuppressed. I want to see the distinct count of orders per manufacturer in that subcategory as a unique value in my viz. So I'm going to save that set. And if I use it in the viz, I'm starting to see information as I expect. Like I see here that all the gray bars are produced by more than 6 manufacturers, but labels and copiers are a subcategory that is only made by a small amount of folks. So how do I now conditionally show those manufacturers and their orders? This is going to be me using the set once again as a calculated field. It is, where's my set? Subcategories, there we go. And all I will do is call this calculation manufacturers suppressed or not, to be or not to be. And this is going to be returning, again at the row level, manufacturers if they are in that set that I do not want to be suppressed, else we want to suppress that information. So I'm going to save that calculation. And by simply bringing this in the detail shelf, I now see Tableau break up all the blue bars into the orders that each manufacturer contributed in those subcategories. And as I change my input, right, Tableau updates the viz and shows those values for the set that meets those conditions. All right, next one, rank comparisons. This is a very, very helpful tool to leverage sets with table calculations. So oftentimes you want to see the overall rank of certain products, certain subcategories, but you may be also interested in seeing how those subcategories or products rank within a certain hierarchy, rank within their own industry or within their own type of product. So in this case, I'm using a category group, office supplies, furniture, or technology. This category group shows me subcategories in my view. So for furniture, we're looking at chairs, tables, bookcases, and furnishings. I'm seeing the ranks for those 4 things within that category as 1, 2, 3, and 4. But I'm also seeing the overall rank based on sales that these subcategories have in my entire table. So although, for example, furnishings is doing pretty well in the context of those values, it's number 11 in my overall sales. So how does this work? I'll start off with this very simple viz that shows sales per subcategory. And the first step in this is to actually add a calculation that calculates the overall rank. And all this is going to be, it's going to be a simple index function. So for every row, give me a number and compute that number based on some dimension I care about. If I use this calculation right in the view, I notice Tableau gives a number to each row, right? And I can compute this just to be safe in case our viz gets rearranged per subcategory. Now this is great, but I want to find this set of subcategories that are in my category group and compute the rank within that. So how do I do that? So we will leverage sets, and again, the idea of max functions within sets, to first define a subcategory set that only returns subcategories in my category group. And I'm going to use all values for this and only condition those values with the max function that checks whether category equals category group. These are all the subcategories in the specified category map parameter. So I've now scoped that information into a set of values I care about. Now I can bring this as a filter, but unfortunately I'm losing the rank of the overall. So how do we do that? We need to use sets now in a calculation to get the rank within that scope. So in order to do this, I'm going to create a calculated field that I'm going to call rank of set. And I'll leverage this function we have in Tableau called rank unique, a simple table calc, which does one simple thing. It looks at the sum of a measure, and this measure in this case is going to be the sum of the sales in my set. So if subcategories in my category group, then sales. And it's going to give me those into descending order. So this gives me the rank of subcategories in my category group, regardless of what it's being used as a filter in my view. So I'm going to save this calc, and I can simply bring that calc in the view. I'll make it discrete and bring it over to the left of my subcategory pill. And now we see how Tableau has the overall rank on the left and the rank within the specified category in this view. Now I can remove the nulls by excluding those values. And as I change my parameter now, Tableau updates the viz to reflect both ranks of the different scopes I'm interested in. Pretty neat. Awesome. All right, so last example, favorite example. I've been saying this a lot. To be fair, I cannot pick one, I'll be frank. I'm just trying to hype you up with every single one. All right, so this is going to give you a sneak peek on how the Devs on Stage demo worked. Here we're looking at a viz that shows different levels of a hierarchy, but each level is being filtered to information I really want to care about. So for example, if I want to see what the average sales of certain subcategories, like fasteners, how does that compare to the average sales at a different level? I can use sets to filter a pill and return conditionally only those values at the next level. So for example, let me pull up the calculation that we used to do this. All I've done here is I've created let's look at the set first actually. All I've done here is I've created a set called drill category set that has 3 possible values, right? Office supplies, furniture, and technology. Notice what happens when I uncheck office supplies and click technology. I hit apply, and Tableau only returns the subcategories for the selected category. And the way this is done, right, is we're using this set definition in the calculation. And for each row, we are returning the subcategory for members that have technology. So the calculation that consumes this, I've called this selected subcategories. Oops. And this simply says, okay, for each category, give me subcategory, else nothing. So only unpack one level down the thing I care about. Now, the power of sets that we can define a set off that calculation. So for example, if I want to see what manufacturers sell machines, but only for machines, I can create a set from this calculation, specify machines. These will be the categories I want to drill down. And I can use that calculation, that set, in the calculation that returns selected manufacturers. So if you're in the set, give me manufacturers, else give me nothing. So look how simple it is. I'm going to use this calculation directly in the view. And Tableau is only going to unpack the manufacturers for the specified member in my subcategory set. Now, it would be amazing if I could simply click on copiers and see copiers expand. Or move over to furniture, right? Completely change the scope of the category I care about and see that expand and see now how the average values between those 2 different levels relate to each other. So let's go to Tableau 18.3 and see how we can do this with set actions. So excited. Okay, there we go. So exact same viz, right? We haven't changed anything in the calcs I've used. I've just collected all these calculations into this new hierarchy I called asymmetric drill. Again, same calcs we used already. Notice what happens, and same sets down there. Notice what happens when I use my mouse to select headers in this viz. I'm going to click furniture, and Tableau unpacks that. I'm going to click furnishings, and Tableau unpacks that. I can click away, and it resets. I can go to technology, accessories. You can perform this ragged search on a relational database, which is extremely powerful, right, for any scenario you may want to look at comparing values. And as you can see, the average sales update for that level. So want to see how this is built? It's super simple. So in this example, I have the exact same viz. Unfortunately, for the sheet, if I click, nothing works. We haven't set up the actions yet. To do this, I'm going to go over to the worksheet toolbar and click actions. Okay. And now we have a new option here called change set values. This is the new set action. So I'm going to go over here and tell Tableau that this is the action that will drill down from categories to subcategories. So drill categories to subcat. Terrible name, but we're going to live with it. So on select, pick my source, my data source, and pick the set I want to target. Just like any other action, there's a source sheet or source sheets, and a target. In this case, instead of a target filter, a target sheet, we have a target set. And I can decide to do different things when I clear my selection. In this case, I want to reset everything, so I'm going to decide to remove values from my set when we're done. I'll save that action, save that again, and zoom out. Now, when I click furniture, notice how Tableau understands what I've selected, updates my set, which updates my calc, which updates my hierarchy, shown in the view. Unfortunately, we haven't set up another action to go down the manufacturer level, so we can simply do this. Again, go over here, really simple, right? New action, two manufacturers. God, this word is hard to type. Okay, select, right, again, target the set that is in this data set called drill subcategory set, remove all values, save that action, go back, and now clicking on tables, unpacks tables. Right, super simple. Now all your consumers can leverage all this analysis we've built when using a dashboard, when using a worksheet that you have authored. So we've wrapped up the examples. I want to go back and summarize the key lessons I want you to leave this session with. Again, nothing hiding under here. All right, perfect. Oops, sorry. All right, so two fundamental concepts, right? We looked at this idea of pill-level filtering as a key tool to leverage and answer set questions. Conceptually, right, our goal in the part-to-part example was to define two instances of a measure, right? We wanted to filter a measure only for some values of a field, right? And save those two instances for later use. And in practice, we express that by using sets in calculations. Instead of using a set as a filter, we use it as a tool to derive insights and save that in our data model. And again, the same exact concept, pill-level filtering, is what we did for the hierarchy drill down, right? We were filtering pills by picking values at a higher level. So in the case of a hierarchy, right, we were looking at the category set and had this calc that returned subcategories that only matched that condition. Now, the second thing we looked at a lot is connecting domains, connecting fields, using sets within sets, using parameters within sets. And fundamentally, right, the idea of filtering one dimension by another dimension is a core thing of what makes sets extremely powerful. Again, we're not filtering a sheet. We're trying to keep information in context to compare and derive further questions, right? So in the example, if you're looking at finding which customers bought X, we're looking at the customer level, but we're getting the results aggregated to that level from a different calculation that may not be the customer. And I mentioned this right at the start, like a set is like a LOD calc that returns 1 or 0, true or false. So if we can use that to answer more questions, right, sets can be really powerful in your analysis. So I'll leave you with this quote by Lorna, one of our Tableau ambassadors. I saw this quote earlier this summer, and I was like, oh man, that's exactly how I feel, because when we're trying to unpack sets and find ways to improve the feature, it was really hard to think about, where they can be applicable. But fundamentally, any filter operation uses set functions. Any set tool that you may be using can filter, can compare, can highlight things in context. It is extremely powerful. So I really encourage you to think of ways you can leverage sets in your analysis. Feel free to question whether they're the best tool for the job, but do think about ways you want to include them in your Tableau visits. And if you have any questions, I'll be more than happy to discuss those with you later. So please complete the survey, help us make this session better for next year. And anytime you want, don't be shy, reach out to me via email, via Twitter. I'm happy to discuss product feedback, debug workbooks with you, help you find your answers to your questions. Again, don't be shy, please reach out. Thank you so much, and thank you for coming.